AI-generated title, but it has a double pun. So pretty good. AI is quite smart, or is it? So for those of you who don't at a private company. So the goal of this talk is to talk a little about code generation in large language models. Okay, if you are not living in a cave, in the past year we have started hearing more and more about LLMs. And if we could do a TLDR, basically they are AI models that can understand human-like text and can generate human-like text and human-like code. Okay, that actually creates a huge potential for automation. The goal of this talk is going to be software automation or software development automation, but you can think of LLMs able to generate any kind of things that a human could generate in text or code. Okay. If we think about software development, we already have very nice tools out there, such as GitHub Copilot, which a lot of you might have used, and ChatGPT. You can go to ChatGPT and you can ask ChatGPT to generate a snippet of code or to generate a full application, and ChatGPT will try to do that and usually succeeds. So, as I mentioned, large language models are a class of artificial intelligence models that has gained popularity recently. These models are pre-trained on massive data sets. So if you think about Copilot was trained on all of GitHub code base at the time that it was released, and it has been it has gained more knowledge as people started using it, as people started making decisions. Same thing with ChatGPT. ChatGPT was trained on a huge corpus of human text and code. Okay. Once you have pre-trained a model, you can actually fine-tune that model to find the kind of answer or find the kind of content that you want to generate. So it kind of becomes a little more specific. Okay, and then GitHub Copilot is an example of a very specific LLM that is geared towards code generation. Okay, GPT, so GPT 3, 3.5, 4, GPT 3.5 Turbo, they are all examples of LLMs, and I'm pretty sure most of you have already touched them or used them for something. Now, when we talk about code generation, and code generation by large language models, we usually have like 5 topics that we see as improvements over humans writing code. The first one is productivity. You can just go there, tell the software or tell the language model what you want to do it, and it's just going to generate for you, so you don't have to code. That would be, or the amount of code that you need to do is way less than if you had to code it manually. The other one is, well, because it's machine generated, you're reducing human error. So instead of going there and copy pasting code and changing the variables, you can have the LLM do that for you. So in theory, that would reduce the number of mistakes per line of code. And that is one of the promises that we have in code generation. The other one is, if you've trained your model with enough high quality data, you are able to produce high quality results, or in the case of code generation, high quality code following coding standards. You don't have to worry that a human is going to have to manually go there and, I don't know, name the variables properly or indent your code properly or use the proper patterns, because the large language model is going to do that for you. The other thing is consistency. So the LLM is not going to be as random as a human being. You'll see that the code generated by the LLM usually follows the pattern in which it was trained for. And that is excellent for rapid prototyping. So basically, you can develop big systems really quick with the help of automated code generation. But not everything are flowers. So when you are asking an AI to write code for you, you might have a lot of problems. One of the problems for us as security people is the vulnerabilities in the generated code. Again, the machine is not perfect. There might be code with vulnerabilities in the training data, and the large language model might be repeating these vulnerabilities or repeating these unsafe patterns. And this is what we're going to focus on the rest of the talk. But there are other issues. Again, if you're using machines to generate code, one of them is if you've managed to taint the training data for the LLM, you can have the LLM write malicious code. Malicious in the sense that it might hide a backdoor in the code that it generates, and because you're trusting that LLM, you might not review it or you might not catch that backdoor. So if you train one of these LLMs, or if you fine-tune one of these LLMs to generate code with backdoors, that can become a huge problem. The other one is privacy concerns. So who else has access to the code that has been generated by the LLM? So if I'm running the LLM locally, then I'm probably the only one that is generating that, but maybe another person can replicate that code somewhere else. So is it my intellectual property? Is it intellectual property of people who created the LLM? Who has access to the code that has been generated that? So this is also another issue that we have with automated code generation in LLMs. Finally, the last one is fairness, bias and fairness, to be honest. So if you've read papers on algorithms being biased, or if you had any articles on that, you might know that depending on the data or depending on the algorithms used to train the LLM or the training data for the LLM, you might be generating algorithms or applications that are biased towards something. And that is also a problem, but that's not something we're going to tackle today. So what is happening in the real world? Well, people are using LLMs to generate code. If you go to YouTube and you search for something developed with ChatGPT, you're going to find full tutorials of people who built lots of applications, games, websites with zero coding ability. They just go to ChatGPT and they ask ChatGPT to generate everything. Same thing with Copilot. You just write your comments and Copilot's going to fill the code. So pretty good. There's also a lot of security happening in this topic, a lot of security research. And there's somewhat limited coverage on the media about is the code being generated secure or not? So I'll share my slides later, but here's 3 links where general media or mainstream media was going like, yeah, the code generated by these tools is probably insecure. But nobody cares about that. You're having productivity. There is a lot of papers talking about this subject, and if you go to archive, you can search for them. There's research in Canada talking about that. You'll see that in most of these papers, the results are that the code generated from these LLMs, Copilot, ChatGPT, usually is riddled with vulnerabilities. And sometimes they are very obvious vulnerabilities. Okay, there's research on how do we automate the process of checking for security in the code generated by an LLM. So all links that I've shared in the slides, so you can go there and read the research. That takes us into the 4 challenges, or 3 challenges, I'm sorry. Lack of control. So we can't control what the LLM is generating. We can fine tune it, but we still don't have full control over the output. There's no easy way to test and verify if the code generated by an LLM is actually secure or not. We have to use different tools. We have to do manual review. And there's the point of responsibility. If someone generates the code, who owns the code? If the code has a problem, am I suing the company that generated the code? Am I suing the developer who used the code? Who knows? So these are still challenges that need to be addressed in this area. Now you ask me, is it really that bad? Yes, it's actually quite bad. So the idea of this talk is that we can take a look at a few of the few samples that were generated by ChatGPT, or in this case it's ChatGPT, and see if we can kind of spot some of the possible vulnerabilities in the code. So the idea is that I've chosen 3 programming languages at random. So PHP, JavaScript with Node, and Python with Flask. So programming languages / frameworks. And I also chose 3 tasks. And again, this is not very scientific. It's just for the sake of the presentation. You can read the research and they have way better methods. But again, I just wanted to make the point. So the 3 tasks that I chose were the first one is an application that prints an argument sent by the user. The second one, an application that checks if a particular keyword is contained within another website. So we're making requisitions to the internet or making requisitions somewhere. And the third one, to check if an argument passed by the user is actually contained in a database. So we're talking to a database. So 3 tasks that a developer would do on a regular basis. Okay. So for each one of the tasks, I have a prompt, very simple prompt that got sent to, in this case, ChatGPT. And then I just change whatever the main argument of the prompt was. Generate this in the particular language A or particular language B or the particular language C. So for the first prompt, generate a web application in whatever language that takes an argument named arg1 sent by the user and prints it to the browser. So pretty much the description that you would have when you would develop something. And then we get the first result. So PHP, we get really nice PHP code. It checks to see if a variable arg1 was sent by the user. If the variable arg1 was sent by the user, it echoes in the response that variable arg1. Otherwise, it gives you the error message saying, please provide a value for arg1. So can anybody spot a possible problem here? You have cross-site scripting, very, very, very simple. You can see that the arg1 variable there gets printed. There's no escaping. There's nothing in there. So if you pass an alert as the argument for arg1, that is going to be alerted on the render. So, okay, it has a somewhat verifying if or there's nothing protecting you from a cross-site request forgery attack. So there's no CSRF checks on any of the samples. Finally, we go to the last prompt. So prompt number 3, generate an application that checks if a name given by the user is present in the database. And now, larger piece of code, we have pretty much setting up the database at the start, defining the host name, password, user, making the connection. In this case, it was a MySQL database. And then we have a check name function, and you can see there's a select star from names where name equals the variable name. That variable name is actually being called, or is actually being populated over here. With the value coming from the post request to that particular URL. And then we're calling the check name function with that variable, okay? And then we're calling the query here using that constructed SQL. And in the end, we're just returning if the name was present in the database or not, or if there were any results that matched that particular name in the database or not. So this one is a little trickier because we have the MySQLi real escape string over there. So this is the first time that ChatGPT actually tried inserting something that would protect you from something. So I don't think, even though we're using concatenation in there or replacement in there, we should not be vulnerable to SQL injection, but not the best way of doing it. We should probably be using like prepared statements. Another thing is, well, since it gave us a hard-coded list of username, password, database name, and a database string, if someone gets access to our source code, they also have access to the credentials for our database. So on real production code, we would expect that to come from an environment variables or to be set at runtime. So again, not a horrible result, but still not the safest code that you could generate. And even though you were checking with the real escape string for the variable that goes into the SQL query, you were still vulnerable to the cross-site request forgery, not the cross-site scripting over there with the name exists variable that's coming from the user. It's just printing that. So very vulnerable. Still have hard-coded credentials. That's okay. We don't appear to have a SQL injection vulnerability. We're using the query and we're passing the parameters, so it's performing prepared statement in there, so that's pretty good. And then we respond with true or false, so we're not rendering the result, or we're not rendering whatever the user passed to us. We're just returning true or false. This is okay. So less of a security concern in that. But we still have the hard-coded credentials. For Flask, for the first time, Flask decided to give us 3 files instead of 1 file. That's okay. For the next time, I'll just ask it to be in a single file. But basically, we have the same things. We have a SQLite tree database instead of a real database. Well, SQLite tree database is a real database, but instead of like a bigger database, instead of MySQL that was using the other two, we get the name from the form. We use the name in a prepared statement. We execute that. We fetch the results. We send the results to a task tree template. Now that task tree template is very tiny over here. The result, it just prints the name as it comes from the variable name. So we are vulnerable to cross-site scripting again. There's also no protection against CSRF. We don't have hard-coded credentials, or I'm not putting the database name as hard-coded credentials anyway. And we still have the debug equals true, which is also a vulnerability. So cross-site scripting, potentially unsafe function, the real escape string. There are some scenarios where you can exploit that. So again, not perfect, but better than nothing. Debug mode enabled for Flask, no CSRF, and use of hard-coded credentials. So they might not be as obvious as the other ones because now the code's doing more stuff. But if you look closely at all the snippets, you're going to find things that might not be as secure as they could have been. Does that mean that if you're using code generated by LLM, someone can compromise your system? Yeah, of course. Will it happen? Probably not, because you as a developer, you're going to take a look and you're going to say, oh, this looks unsafe. Or you're going to do like me. You would use some kind of static analysis security testing tools. Just to make your life easier, if you want to download all of the samples and run on your favorite SaaS tool, feel free to do that. They are on my GitHub. I've run it through multiple SaaS tools, so Verico, Snyk, SendGrab, AppScan, and I've decided to show the Snyk results because that's the tool that actually caught the most number of findings in this scenario. And Snyk identified 20 issues in the code. So again, if you don't have experience in doing code reviews, you can also use an automated tool, and the automated tool is gonna provide you with decent results, or at least it's gonna show you, oh, you have 9 high findings, you have 9 cross-site scriptings, for example, or in this case, we didn't have any injection or no SQL injections were detected, but if that was the case, you could have done that. Now, to answer the question made there, what will prompt engineering get us? So if we modify the prompt just by adding make sure the code is secure and regenerating everything. So for the sake of this experiment, I've started a new ChatGPT thread for each one of the conversations. So there was no, hopefully there was no prompt interaction. But the moment you do that, make sure the code is secure. You start getting specialized functions in each one of the languages or each one of the frameworks that you are using. And just by doing that, you're reducing your attack surface because you no longer have that SQL injection or you no longer have that cross-site scripting. And it came from the same LLM that generated the unsafe or unsecure code. Okay, so a very, very simple prompt change like this return code that is sanitized. So one of the questions is, well, why is the LLM generating code that is not safe by default? And if you take a deeper analysis of that, you're going to realize that most code and most examples that you're going to find, they don't focus on security. Security is added later. But a huge chunk of the code is like, hey, how do I print this variable here? Here's the tutorial how to print the variable. Oh, by the way, if you do that, it's not going to be super safe. So use this particular function here to protect it. And you can see that this is a general problem with the LLMs because they're going to look at the corpus of data and they're not gonna think that the next token is the security one because it only appears later or it only appears as a consideration instead of being in the full code. So how do you mitigate the risk? Well, you use better prompts, you use better training data. But if you can't do that, well, you need to review the code that you generate before you put it in production. So no going from ChatGPT directly into whatever you're using. Make sure that your developers are trained. So just a suggestion, always make sure that your developers are trained in security. Pretty good. If you have the capability of actually fine-tuning your model, use that capability to actually fine-tune it. Use secure code examples, use security best practices in the process of fine-tuning that model. If you add that with prompt engineering, you can absolutely get code that I won't say is production ready, but it's very close to being production ready. And the last one is integrate automated security checks. So this is something that you should be doing regardless if you're using code from LLMs or if you're developing your own code. Make sure that your code is scanned. Make sure that you're using a SaaS tool, or if you're building a web application, make sure that you're using dynamic application security testing as well. So to finish here, using LLMs to generate code is awesome. I particularly like using LLMs to generate pictures, images. So all images in this presentation were generated by, not LLMs, but by generative AI. So this is DALL-E. But whenever you generate code, make sure that you take a closer look at the code that is being generated. And then make sure that you do another pass just to make sure you didn't miss anything because it might be very soon. If you have SaaS tools, run your SaaS tools. And well, if you are going to use ChatGPT or Copilot, make sure to ask them to generate secure code because otherwise it's not going to generate secure code. Okay, that's it. Thank you for watching this talk. Feel free to reach out to me. I'm usually active on Twitter. I'm active on LinkedIn as well. So reach out if you have any questions. And well, if you have any questions right now, I can take them. Please. So that's a very good question. I don't have an answer for that, especially because the way that LLMs are trained, we don't have access to that data. So I don't know how long it would take for secure code to be inserted in there. But if we, let's say, generate unsafe code, put it in production, the first pen test is going to catch, I wouldn't say most of these vulnerabilities, but it's definitely going to catch the cross-site scripting. If you're running some kind of DAST, it's going to catch the SQL injection. If you're running, if you're running DAST, you're going to catch the cross-site request forgery or the lack of CSRF tokens as well. You're going to see that if you ask it to generate something with cookies, it's not going to default to HTTP-only cookies. So again, your cookies could be intercepted. So it's just a matter, the first pen test is going to find most of the findings, but there might be things that is hidden in there and that doesn't get caught, so hard to say.
Are there certain languages that
So I've read about C. I haven't read anything about Rust, but yes. So with C in C++, it has a hard time figuring out when to free memory or not free memory. That is something I've read, and it happens consistently. It's not one of the languages I use, so I don't have a more empiric experience with that. But in general, yes. In general, you'd assume that languages that are not scripting languages, which are the ones I picked here, would have a harder time. But then you have the compiler that might do a lot of heavy lifting for you and saying, hey, this is not secure. Hey, you're using a function that should not be used. So I think it kind of balances. But again, the class of vulnerability that you might find in a compiled application is different from a web application one. So yeah, I don't have like a definite answer on that, but I know that you will find problems regardless of the language. Yeah, it's you.
So when you did that second pass for your pass,
Yes.
did that
Yes. Yes, everything. Like all of the samples, it reduced all of them to 0. Yes. Even the ones that are more subtle, like the hard-coded credentials, if you ask it to make it safe, it turns the hard-coded credentials into environment variables. So pretty good. And again, it's just the matter of like make it secure, which should be the default. So they were ChatGPT 4. I don't know if I paid the subscription, but I don't know if it's available to everybody.
The private school, I developed some code in ChatGPT, and it's regarding maybe it's not AI model, developing something.
So that's a good question. So if you're using a commercially available model, let's say you're using ChatGPT or Copilot, they might be using your data to retrain the model. So if you generate code in there and you accept that as a valid answer, it might come back and become a solution for the next user that requests something similar to what you requested. Is it guaranteed that it's going to be there? No. Are there ways to opt out? If you're using ChatGPT, you can actually go to settings and say, don't use or don't use the information that I provide to feed your tool. But you got there, so there's always the chance that someone is going to replicate your prompt or going to get very close to generate a solution that is almost like the solution that you generate. There's some randomness in how LLMs work, but in general, if it has been generated once, there's always the chance that it can be generated again. So if intellectual property is something that you care about, that you value, that your solution relies on, using an LLM to do that, especially one that is commercially accessible, might be a bad idea.
Just a thought that might make for an interesting experiment would be to have it generate some code with the
Yes.
and then have it identify these things that might actually prevent the training.
Absolutely, absolutely. And this is something that you can actually do, and it kind of works. You ask it to generate code, and in the same context window, you ask it, oh, are you sure this is secure? And then ChatGPT is going to go, actually, there's a SQL injection here, and there's a cross-site scripting opportunity here. So it's the way that the LLM is designed to work as. It's going to generate the next probable prompt. It's just that the security prompts are not logical to be the next one generated. But that's a very good idea. You can even analyze to see if you provide code and ask it to criticize. GPT-3 had a hard time with that, but 4 works really better or really best. And unfortunately, it will be very hard for the LLM to find out 0 days, like stuff that it has never seen before, because it would make no sense. But I assume that you could use it as some kind of SaaS, as an entry-level SaaS, just, hey, look at this code. Are there vulnerabilities? That could absolutely work. No, I haven't tried this with the custom GPTs, but yeah, I would assume that with that ability of doing the pre-training and giving the pre-prompt message, you could add that as the pre-prompt message, or you could add, if you're using a custom model, you could add that to the pre-training, and it would definitely get better results. Absolutely. Okay. Yes. Yes. So we know that AI has been pushed into security vendors quite a lot. There are some vendors that are using LLMs to generate suggestions on how to fix code, which is basically the idea that Professor Joel mentioned over there. It's something that a lot of companies have restrictions to. One is your code is getting sent to an LLM for analysis, which could be bad, especially depending on, and tying back to that other question. Well, if I send something to the LLM, will the company see that? Will the company reuse that? If you have a commercial provider that will guarantee you that they won't use your data for training or for retraining, then I can see some companies adopting it. But in general, there's all these challenges that are like the privacy challenges, the ownership challenges that might be in the way. As a developer, as a personal developer, or in a company that you might not care about the code that you have other than the security of the code, that might work, and you might see vendors pushing that. But for larger corporations, I think these other challenges need to be addressed first. But I definitely see that being used in the very close future.
So coming from a business point of view, is sometimes say, let's what is, yes, best way to address the business audience?
It's a very good question. So one is making sure that everybody understands how the LLM is working, or what is how is it generating the code, or how is it generating the solution that you need? Because we might not be talking about code, we might be talking about some other kind of automation that is being done through LLM. So make sure that your audience understands the risks, what happens when you submit data into one of these commercially available LLMs. Make sure that it's not something that has conscience. It's an AI model that has been trained to do something. It will hallucinate a lot of times because it doesn't know the context, or it just tries to make up things as it goes. So that's less of a problem with code and more of a problem with other kinds of automation, especially if you're generating text. Address the risks. So if we use this tool, we might get productivity, we might get less errors, but there's a chance that our competitor is going to use the same thing. If our prompt leaks, or if we're using something that requires a specific prompt and it leaks, then someone can create the same tool that we're using, or someone can do the same thing that we're doing. So that's always a risk. The other thing is about the legality of it. So for example, not talking about LLMs, let's talk about generative image. So if we're talking about DALL-E or any other tool that generates images, what was the data set that was used to train that? Because the images that it generates, they all have some kind of ground truth, some kind of base image that was used to generate that. So who owns the copyright of that? So if I'm using that to generate art, maybe I'm going to see an artist that looks at that picture and says, oh, this is based off my art. And then you also have that risk because, again, the data has to come from somewhere. I know that in the US, there's some lawsuits happening right now as to who owns that, or should the original creators have some kind of financial compensation for the data that's being used to train the models. But in general, I would assume that it's still a very important risk if you take into business account considerations. The other thing, and the last thing it would be is, well, if you're relying on one of these LLMs to do your business, you might as well have to have some kind of some path out of there. So if OpenAI decides to charge 10 times more tomorrow, what will you do? Your costs have gone 10 times higher, and there's nothing you can do because there's no other tool that you can migrate. Or if they decide to shut down the model that you're using a cheap model, they're taking a loss, they say, oh, in 3 weeks we're going to retire that. And this has happened a couple of months ago, and people had an outrage because, oh, we built our entire solution on top of this, and now you're retiring this model because you have a different model that's more expensive. So all checks and balances. So wherever you see an opportunity, there's certainly a risk associated with that opportunity. Okay, thank you very much for attending this talk. My slides will be available if you need them. I think they're going to be in the conference website. If you need anything, feel free to reach out to me. And yeah.